Alright, in this video we're going to use what we learned about kinetic energy and potential energy to apply them to some motion problems that we've seen before to make our lives a lot easier. Solving these problems using energy considerations is actually a lot easier than solving for time and velocity and all the things we had to do before. So let's look at a problem we had before that was actually relatively complicated and how we can make it simple using energy considerations. So a boy throws a ball straight up into the air with an initial velocity of 15 meters per second. And I want to know what the maximum height is that the ball reaches. Alright, so when we think about this problem, well, we'll think that the ball at the beginning has a initial velocity of 15 meters per second, which means that when the ball starts, we'll assume that it's starting from the ground, it has only kinetic energy. And when the ball reaches the peak, we said that the velocity was 0 meters per second at this point. So it means it has no kinetic energy at this point, but it has gained some height h. And so we'll say at that point it has all potential energy. And so we know from the conservation of energy that energy is neither created nor destroyed, so that the kinetic energy we start with at the beginning of the problem, it should be equal to the potential energy that we finish with at the end of the problem. Okay, so if the kinetic energy that we start with is 1/2 mv squared, and the potential energy is equal to, this is gravitational potential energy in this case, 1/2 mgh. Now all we have to do is just a little bit of algebra and we can solve for the maximum height found here of this ball. So we see initially that the masses cancel out. We do a little bit of math, so 1/2 v squared divided by h gives me, why would I do that? That was just silly. Divided by g gives me the height isolated. So now I just need to do is plug my values in. So 1/2 times 15 meters per second squared divided by the acceleration of gravity, 9.8 meters per second. I whip out my calculator and I solve this. And I find that the maximum height the ball reaches is 11.5 meters. Now, if you guys don't believe me, you can try and solve this the old way and you'll find that you get the exact same answer. Alright, so that one was a little bit difficult, but I don't think we had too much trouble with that one before. Let's try a new one. It's a little bit more challenging. What about these trajectory problems like this? And so if I had a ball and it was launched from the ground at a 35-degree angle with a maximum initial velocity, or with an initial velocity of 25 meters per second, what is the maximum height the ball reaches? Okay, and so in this case, let's think about what we're dealing with here. So initially the ball starts down here and it has initially it has kinetic energy. We'll say this at this point it would be KE initial. It climbs up to some height up here. At this point it's at the height that we're looking for, and at this point it would have both kinetic energy because it's moving. We'll say KE final, I guess, or something like that. And it has potential energy because now it's some height off the ground. It has gravitational potential energy. So if we put this into an expression, KE initial is equal to KE final plus the potential energy we start with, we can start to solve for our height. So let's do some substitution. So KE initial is equal to 1/2 mass times velocity squared. KE final is equal to 1/2 mass, so this will be our initial velocity here. It's much different. And our final velocity here, when we're at the peak, plus our mass times mgh for our potential. We see that the masses all cancel out because they're in every term. And we can do a little bit of algebra and solve for our height. So let's see, I have 1/2 V initial minus 1/2 V final. And these V's are both squared, divided by G, and that is equal to my height. Okay. I can factor some stuff out. I can say H is equal to 1/2 V initial squared minus V final squared divided by G. Alright, but now we're kind of stuck. So I know V initial is 25 meters per second. How do I find V final so I can finish solving this problem? Well, remember that when we're at this point, the maximum height, it's always equal to the x component of the velocity in the absence of air resistance. Okay? So if I were to solve for the x component of the velocity, I would say that it was 25 cosine 35. Okay. I plug in all of the numbers into this equation and I get 10.5 meters.